Yeah. Okay, YouTube. I just got totally snobbed by a bunch of people about my video quality. So here's my YouTube. I'm making this for supper night. We'll bake rigatoni. I'm gonna make a video. Look for a post it later so my students can show some appreciation to mom and dad and make them supper. So, but apparently my phone might not be good enough or smart enough to be able to have the quality of video that they're looking for. So let's see. Borrow a school iPad. What if I lose it? I don't like Apple. Apple's like non-compatible. I don't do Apple. I'm sorry, YouTube. I don't do Apple. I'm not a proponent. Sorry. Get a tablet from a what? Get a Samsung. You want me to pay money so that you guys can watch my videos? No. Chromebook. Thank you. Go use a Chromebook. So I've seen these cameras that are pretty small, but they're like they you just put in like a flash drive on it, and it takes pretty good decent videos. GoPro. All right. All right. I told you what's not my problem. What's not my problem is this. What's not my problem is that I do know what to make supper tonight. Okay, so I don't have a problem figuring out what to make for supper tonight. I make a baked rigatoni. But what I do have a problem with is I need to try to get you guys to a point where you're able to solve math problems without following examples. Like I could show you an example and I get it. You could go ahead and then follow your notes and figure it out, right? But wouldn't it be nice if you could see a problem from scratch, one that I hadn't shown you how to do, and you could solve it? I would love to help make that happen for you. I don't know how, but I'm going to give you the opportunity today. But that's kind of my goal. So we're going to show you some more examples. We're going to try to help you come up with things on your own. But so like as we look at these problems, try to come up with a moment or an aha point that kind of helps you out. A man's walking away from a lamppost with a light source 6 meters above the ground. The man's 2 meters tall. How far from the lamppost is the man when his shadow is 5 meters in length? What do you want me to start by doing? Draw a picture. Draw what? A lamppost. I'm really good at drawing lampposts. There's a light. What's that? It's like a burning sun on top of a pole. Now what? You guys are in charge. Now what? Oh man. There it is. Yeah. Ooh. So Reckon had just had a aha moment right there. He said, let's produce a triangle. That's super important to the problem. Now what? Right there is 5. And this is the moment. Can something come into your brain? You've got lots of resources out there. What are we going to use to solve this problem? Everybody goes Pythagorean theorem. Pythagorean theorem will not work in this situation. Proportion? Are you saying that we have similar triangles? And why are they similar? Because you have a 90-degree angle, and then they have what we call a shared angle. So if two angles are the same, then the third angle must be the same, correct? And you learned back in geometry that angle, angle, angle is enough to say that two shapes are in fact similar. And if two shapes are similar, then their sides are proportional. Yes, let's set it up. So therefore, we have the height divided by the length. I just like to use two variables to help organize my work. So the height of the man is 2 divided by the length of his shadow is 5. And that's going to be equal to the height of the lamppost, which is 6, divided by what? D plus 5. We cross multiply. We get 2D plus 10 is equal to 30. or 2d is equal to 20, or d is equal to 10. Good job. I don't want to take anything away from the other 2 hours, as they are wonderful, wonderful class periods, but you guys totally rocked it compared to first and third hour. Good job. Should I tell them that tomorrow? Okay. The next problem is one of my faves. 2 flagpoles. One's 13 feet in length. The other one's 9 feet in length. Some grass here. And there's ropes that are connecting the poles from the top to the other's base. At what height above the ground do the ropes cross? Now, you're not going to solve this problem on your own, but I want you to turn to somebody near you and try to say anything intelligent at all about the setup of the problem. Anything. So similar triangles is one way you can set this up. I don't really like the way that works out. Instead, what I do, and this is a great way to do a problem, is just slap on an XY coordinate axis. And it sounds ridiculous, but all of a sudden I made the problem very simple. I just constructed, say this, I have line 1 and I have line 2. And don't we just want to find the intersection between the 2 lines? If we found the height of the intersection of the 2 lines, that'll be where the ropes cross. Agreed? Now I just need equations for lines. Y equals mx plus b. What do you notice about the y-intercept of the first line? It's 0. The slope, what do you rise to get from here to here? To get from here to here, I rise 9. What do I run? We don't know. We'll call it some distance. So therefore, y is equal to slope is 9 over d times x. And the y-intercept is 0. Line number 2, we have y is equal to, what's the slope for the second line? I go from here to here. Down 13 and over d, so negative 13 over d times x. What's the y-intercept? 13. I have 2 equations, 2 lines. I'm looking for the intersection. You can use substitution, elimination, or graphing. I choose to use substitution. I know that the d is bothering some people. Don't let it bother you, okay? Just ignore it for a second. We have 9 over d times x is equal to negative 13 over d times x plus 13. I'm trying to solve for x. So I'm going to add 13 over dx to both sides. And I get 22 over dx is equal to 13. I want to solve for x. What do I do to both sides to solve for x? Times by d over 22. So that allows you to solve for x. X is 13 times d divided by 22. What that means is that the x value for where they intersect, you would take 13 times the distance and divide by 22, and that would tell you the x value. What I want to know is I want to know the y value. How do I figure out the y value once I know the x value? Yeah, I'm going to take this guy right here and plug it in for x there. Y is equal to 9 over d times x, which is 13d over 22. What do you notice? Isn't that great? Like, we were really frustrated about the d's for a while. It turns out they just go away. You get 9 times 13 divided by 22. Which comes out to be 5.32. And for those of you who are kind of interested in the problem, that actually means that it doesn't matter how far apart these are. You can stretch them apart 100 feet, and they would still intersect at 5.32 feet above the ground. You can bring them 1 foot apart, and they'd intersect at 5.32 feet above the ground. Coordinate proof, very, very, very helpful. You guys can handle it. Flip it over. Garrett, I'm going to give you some money. How much money do you want? 100 bucks. Garrett's going to get 100 bucks. Garrett, if you had $100, what would you do with it? Don't say save for college. Buy a pair of shoes. Okay, all right. What's the going rate for a nice pair of shoes these days? 60 bucks. Okay, all right. Buying yourself $60 pair of shoes. Very good. Suppose you did decide to invest it. Okay, suppose you did decide to invest it. And you decided to invest it into, we'll give you a couple options. We'll give you like a savings account in the bank, and we'll say in the stock market, okay? How much you want to put in the bank? You want to put 50 in the bank, and you want to put 50 in the stock market. Okay. Suppose you get 1% from the bank, and you get 10% from the stock market. How much money did you then get from your investment in the bank? If you got 1%, 50 cents. If you got 10% from your investment in the stock market, how much did you get? $5. So how much total money did you invest? What was your total investment? $100. How much actual money did you make extra? $5.50, right? Everybody get it? You see, when you don't know how to do a problem, just do the problem. Do you see how I just took an investment and I divided it up into 2 places? And I said, that's my total investment. That's the amount of interest I have. That wasn't any brain buster work there, was it? So when you see this problem, if you would just look at it straight up, you'd be like, well, I don't know what I'm doing. Well, just do a problem that you know how to do like it. And then I'll tell you how to do this one. Tom's got $9,600 to invest. He invests a portion into a rate at 4% a year. We'll call that investment A. The rest he invests into a riskier market, earns him 10% a year. We'll call that investment B. His total earnings from the interest in the investment were $528. How much did he invest into each place? So we're wondering how much you put into A and how much you put into B. So we have 2 equations. We have the total of his investment, and then we also have the interest of his investment. What's his total investment? $9,600. What's the total interest he got? $528. Can somebody out there please come up with an equation that relates A and B and 9,600? Think back to Garrett's. What did we have for Garrett? We had total was 100 and he had 50 and 50. Gave you the 100, right? A plus B is 9,600. Now, how did we come up with Garrett's interest? We multiply 5%, so come up with an equation that relates A and B and 528. 0.04A plus 0.1B is equal to that. Everybody see how this follows what the example we did with Garrett? You understand Garrett's example was easier because we were working with $100. So model a problem with an easier problem if you don't know how to do it. Now, we got two options, substitution or elimination. I like elimination here. Whoops, no parenthesis there, over here. I'm going to multiply through by negative 0.1. This is a free country, I'm going to do whatever I want to do. And I get negative 0.1a minus 0.1b is equal to negative $960. Add them together, and I get negative 0.06a, those cancel, equals negative 432. Divide by negative 0.06, and a is 7,200. So you had $7,200 at 4%. And then how much did he have at 10%? 2,400. We do one more problem today. And as we do this last problem, what I want you to do is I want you to see if you can set it up. Don't solve it, but take a minute, try to set it up, talk with your peers, see if you can. What do you got? A plus B is equal to 300. That's the total amount of mixture that you need. Excellent. Point 0.6a plus 0.3b equals 0.5. Anybody else get the same thing? Okay, what about anybody else get anything different? Okay, so this is the most common response. There's a lot that's really good about this. First equation is completely right. Second equation is 90% correct. There's just one part that's not quite right, okay? What you're saying here is that you have 300 milliliters of total solution, and then you have half a milliliter of acid. That's what you're saying. Do we want a half a milliliter of acid? How much acid do you want? You want 150 milliliters of acid. You see that? We want the actual amount of acid. How'd you come up with 150? Yeah, it said 50% acid, so 50% of 300 is 150. So I let you do that so you could go down that thinking path, because if I allow you to go down that path and then bring you back from it, you're more likely to not make that mistake than in the future, okay? So I'm going to multiply the top through by, I'm going to go 0.3. And I get negative 0.3a minus 0.3b is equal to negative 90. Add that together. 0.3a is equal to 60. Divide by 0.3, a is equal to 200. B is equal to 100. So we have 200 milliliters of the 60% and 100 milliliters at 30%. Can you see how that will be important to a chemist? And the fact is, folks, is that once we set it up, you've got no problem doing the algebra. There's no problem that you have doing the algebra. But the setup of the problem, that's what's special and unique. So the rest of the time is yours. Take out your worksheet that I gave you.